Hello student, in this video we will see the question answer on page number 176. The first question, a ray of light traveling in air enters obliquely into water. Does the light ray bends towards the normal or away from the normal, and why? A ray of light traveling in air to the water as it given into the question. So we can come to know that the light is traveled from rare medium to denser medium. How we can come to know that air is a rare medium and the water is denser medium? By the refractive index. Because the air refractive index is 1.0003 and water refractive index is approximately 1.33. So, whenever the light is traveled from rare medium to denser medium, at that time it is slightly bent towards the normal. Why it is bent towards the normal? Because whenever the light enters from the rare to denser medium, the speed of the light it becomes slower. Due to that, the light ray is bent towards the normal. Let's see the answer. The light ray bends towards the normal when a light ray enters from an optically rare medium. Optically rare medium means a medium which has a low refractive index, to an optically denser medium means which has a high refractive index. Its speed slow down and bends towards the normal. As water is optically denser than the air, a ray of light it's entering from air into the water will bend towards the normal. Let's see one more time. A ray of light traveling in air enters obliquely into water. Thus, the light ray bends towards the normal or away from the normal. And why? The answer is the light ray bends towards the normal when a light rays enter from an optically rare medium means which has a low refractive index to an optically denser medium which has a high refractive index. It is speed slow down. Why it is become slow down? Because it is entering from the rare to denser medium and it is bent towards the normal. As the water is optically denser than the air, a ray of light entering from air into the water will bend towards the normal. Now let's see the question number 2. The light enters from air to glass having a refractive index 1.50. What is the speed of light in a glass? The speed of light in a vacuum is 3 into 10 raised to 8 meter per second. Here you can see that the light is entered from air to glass means rare medium to denser medium. And two things are given. First thing that is of refractive index of the glass is given, that is of 1.50, and the speed of the light in the vacuum is given. It's a 3 into 10 raised to 8 meter per second. So, as we know, the formula of refractive index of a medium is equal to a speed of light in a vacuum divided by a speed of light in the medium. But here we have to find out the speed of light in the glass. So we can make one formula from this formula, that the speed of the light in the glass is equal to the speed of light in vacuum divided by the refractive index of the glass. So if we are keeping the value the speed of light of the vacuum is given. It's a 3 into 10 raised to 8 meter per second, and refractive index of the glass, that is a 1.50 given. So approximately your answer is 2 into 10 raised to 8 meter per second. Let's see the answer. The refractive index of a medium is equal to the speed of light in a vacuum divided by a speed of light in the medium. The speed of light in a vacuum is equal to 3 into 10 raised to 8 meter per second. Consider it as a 10 raised to 8, not 108. And the refractive index of glass is also given. It's a 1.50, and speed of light in glass is equal to the speed of light in vacuum divided by refractive index of the glass. This formula is made from this formula only. So here we are keeping the value. The speed of light in vacuum is a 3 into 10 raised to 8, and the refractive index of the glass is equal to 1.50. So the answer is 2 into 10 raised to 8 meter per second. Let's see one more time. The light enters from the air to glass having a refractive index 1.50. What is the speed of light in the glass? The speed of light in vacuum is 3 into 10 raised to 8 meter per second. So as we have the formula of the refractive index of medium is equal to the speed of light in vacuum divided by the speed of light in the medium. So the speed of the light in the vacuum is equal to 3 into 10 raised to 8 meter per second, and the refractive index of the glass, that is also given, that is of 1.50. So the formula it's become speed of the light in the glass is equal to a speed of light in vacuum divided by a refractive index of the glass. If we are keeping this value, the speed of the light, that is 3 into 10 raised to 8 divided by the refractive index, that is of 1.50. So our answer is 2 into 10 raised to 8 meter per second. Let's see the question number 3. Find out from the table the medium having the highest optical density. Also find the medium with the lowest optical density. How we know about the density? By the refractive index. The more refractive index means the more density. Less refractive index means less density. So here you can see the air possesses the lowest refractive index, that is of 1.303, and if we are talking about the highest refractive index, that is of a diamond, and it is a 2.42. So, and rest of the all the materials is between this air and the diamond range. So our question is that find out from the table the medium having a highest optical density. As we see that highest optical density, that is of diamond, and also find the medium with the lowest optical density, so that is of air, because the air possesses a refractive index 1.0003, whereas a highest refractive index that possessed by the diamond, it possesses 2.42, which is the highest refractive index. As we know that the refractive index is directly proportional to the density, means the refractive index is more than the density is also more. So the answer, let's see the answer. The lowest optical density is of air medium, and the highest optical density, it is of a diamond. The optical density of a medium is directly related with its refractive index. A medium with the highest refractive index will have the highest optical density, and vice versa. Means those medium who possess the highest refractive index, that means it possesses the highest optical density. Those medium who possess the lowest refractive index, that means it possesses the lowest optical density. So it can be observed from the table that air and the diamond respectively have the lowest and the highest refractive index. Hence, air has the lowest optical density and diamond has the highest optical density. Now let's move further. The question number 4. The question number 4 is, you are given a kerosene, turpentine and water. In which of these does the light travel faster? Use the information given in the table. The question is that you are given two, kerosene, turpentine and water. In which of these does the light travel faster? Use the information given in table. As we know that if the refractive index is more, that means the density is more. If the density is more, then the speed of the light, it becomes a slow down. So we can say that the speed of the light is inversely proportional to the refractive index. Means if the refractive index is high, then the light of the speed is low. If the refractive index is low, then the speed of the light is high. So let's see first the kerosene, turpentine and water refractive index. Here you can see the water refractive index is a 1.33, whereas kerosene possesses 1.44 and the turpentine possesses the 1.46. So here the question is that in which medium the light speed is faster. So as I told you, in which medium which possesses the lowest refractive index, that means the lowest density, so the light travel can faster. So as compared to the turpentine oil, kerosene, the water possesses the less refractive index. So the answer is water. 1.33 refractive index is there, water. So in the water, as compared to the turpentine oil and the kerosene, in the water light speed is a faster. Let's see the answer. The light travel faster in a water as compared to the kerosene and the turpentine, as the refractive index of a water is lower than that the kerosene and turpentine. The speed of light is inversely proportional to the refractive index. Let's see one more time. The question is that you are given a kerosene, turpentine and water. So in which of these does the light travel fastest? Use the information given in the table. So first of all, we have to see the refractive index of these three things. Water possesses a 1.33 refractive index. Kerosene possesses 1.44 refractive index, while turpentine possesses 1.47. So as I told you that the refractive index is inversely proportional to the speed of light. That means if the refractive index is more, then the speed of light is less. If the refractive index is less, then the speed of light is more. So from these three of them, the water possesses the lowest refractive index. That means it possesses the lowest density. And that means the light can move faster in this medium as compared to the kerosene and the turpentine. So the answer is the light travel faster in water as compared to kerosene and turpentine, as the refractive index of water is lower than that of a kerosene and turpentine. The speed of light is inversely proportional to the refractive index. And student, kindly write down this all the question answer, and for best application for it, solution, The Vedantu NCERT solution is there. So kindly download it, and from it you can write down the question answer of the exercise easily. Thank you.